Hello everyone, welcome to my channel. If you are new to this channel, please support the channel by subscribing and sharing my videos with your friends. Now let's get into the video. In this one, I have one integral to work on. It's the integral of 1 all over 1 minus e to the power x dx. The approach is as follows. So we have the integral of 1 all over 1 minus e to the power x dx. Now this is one of those integrals where direct use substitution will not work. Looking at e to the power x here, we are going to use what I call the special one as follows. So we have this integral is the same as the integral of, watch this, e to the power minus x all over e to the power minus x times 1 all over 1 minus e to the power x dx. Now you can see that this is just 1. These can cancel, it's 1. But we're not going to cancel. We distribute in the numerator and in the denominator to obtain the following expression in the integrand. So this is going to be the integral of e to the power minus x all over e to the power minus x times 1 is e to the power minus x. E to the power minus x times e to the power x, you agree with me that the answer is just minus 1. Remember laws of exponents, minus x plus x is 0 and e to the power 0 is 1. We have dx. Now, fantastic. So now I'm going to use substitution. But before I do that, I'm going to combine this and that. So I'm going to take this to the third step as follows. This same as integral of 1 over e to the power minus x minus 1 times e to the power minus x dx. Fantastic. Now I can let u be equal to the denominator. So now I'm going to say let u be equal to e to the power minus x minus 1. Differentiating both sides, you agree with me that du will just be equal to minus e to the power minus x dx. Derivative of minus 1 is 0, minus 1 being a constant. Now if you look at this part here, we have e to the power x power minus x dx, and therefore we don't need this minus sign here. So I'm going to have to multiply by minus 1 both sides to obtain the following expression, taking us to page 2. So now I'm saying what we have now is minus du, the answer will just be equal to minus du, the answer will be equal to e to the power minus x dx. Fantastic. Now this expression here is exactly the same as this expression as you can see here. Therefore that integral now changes as follows. I'm going to say that integral is the same as the integral of 1 all over u. Instead of having this expression, I'm going to have minus du, terms of minus du. Minus 1 is a constant, take it out. So just have minus the integral of 1 over u du. And obviously you'll agree with me that this is just minus natural log of u. And then we have to say plus c, constant of integration. Now this minus sign here, if you don't want it, we can actually take it up using laws of exponents, laws of logs. This is the same as the natural log of u to the power minus 1. And we have to use the absolute values there, plus c. This expression inside there is just, as you can see, it's going to be 1 over u, natural log of that, plus c. Now let's revert to our original variable. Now our original variable is x obviously, and the connection is this one here. E to the power minus x minus 1 equals u. So I'm bringing that expression down here, taking us to page 3, and just to complete this, and then we're done. Let's see. Let me put the papers in order. So I'm saying now that what we have is that this expression that you see here, this one, is the same as natural log of 1 all over e to the power minus x minus 1, and then we have to say plus c. Remember, u is this expression here as I showed you over here. Check this. The connection is this one here. U is e to the power minus x minus 1. So we put it in that place. And let's simplify this. Simplifying this, you'll agree with me that this is the same as the natural log of 1 all over E1 over e to the power x minus 1 plus c. Now this expression in the denominator, you'll agree with me that it's the same as we have natural log here of 1 all over. This one in the denominator, we have 1 minus e to the power x all over e to the power x. If you agree with me there, in terms of simplifying that, remember this is the same as e power x over e power x. And when the denominators are the same, what do? You just take the numerators, put them together. So 1 minus e power x over e power x, like so. And then plus c. This is just, if we rewrite it, it's just going to be the natural log of, watch this, e to the power x all over 1 minus e to the power x. And then we have to say plus c. Fantastic. This is our final solution to our integral. I had to simplify it to this step because if you pay attention to the original form in which the question has been posed, you see that we have this expression 1 minus e to the power x. I wanted to have that in my final solution, and that's why you have that in the denominator there. But otherwise, if you wanted, you would have left it at which step? You would have left it at this step. It would still be just fine, but simplifying is even better. So this is our final solution to that integral there. What do you think about this integral? Tell me what approach you would have taken to arrive at this solution here. Would you have applied what I call the special one? This one here, that's our special one. This expression here, this one here, I call it the special one. That part there, that part. Would you have applied that? I'm interested to hear from you. All right, I'll see you in the next one.